see you.
Good to see you.
Hello, everyone. So we have some people. Okay, that's great. Nikita, thanks for making time.
Of course.
Thanks for coming. Sort of to kick it off, like you've been in distributed systems your entire life.
Correct.
And now with this sort of like, you guys have been also on the receiving end successfully of agents. And so what has sort of changed historically from your view, what we did or what you had built on before, where humans were the number one user now versus agents?
Well, I think the whole industry, and specifically the database industry, but we can expand it to distributed computing as well, was trying to solve for scale. And the reason to that was, like Meta and all this like very large Uber, large web destinations, that's what they needed, right? They needed a single system that can go and run at a very, very, very high scale, sustain lots of traffic. We had lots of technologies that support that. I don't know, Kafka, for example, that comes to mind, that can collect lots of events and push it through. When agents arrive, there's a new use case that showed up, which is very, very large volume of small things. And what I mean by that is you can imagine something like, I don't know, Replit or Lovable or Cloud Code. It's possible now to generate lots and lots of small applications. And now we'll look at the typical application stack with like storage, compute, database, and it's like, well, now multiply that by, I don't know, 10 million, 20 million, 100 million, right? So each individual case is very, very small. The velocity of it is insane, right? I think Neon is approaching 100,000 databases spun up every day. But then, like the economics need to make sense. Not only you need to do it very, very quickly. How many people observe that GitHub's down?
Oh yeah.
Yeah. So why is that? Well, same story, right? It's a lot of very, very small use cases. So now the dimension at which you need to scale changes. So the number of instances of whatever you're providing, sandboxes, databases, storage, compute, GitHub repos, that needs to stretch. And that puts pressure on the architecture. But I also think we're like really in the first inning of that.
No, for sure. And I know when we were talking at the sandboxes, because we used to do dev environment automation. And so the first version of Daytona, we'd spin up, your dev environment is probably a Kubernetes cluster, right? It was like really, really big. And I remember talking to my CTO, look, sandboxes are great. It's just like one container, right? Because they need very, very small use cases. Right. Now, fast forward a year, we have customers saying, oh, we want the agent to replicate the same human, really big, really scalable. So like, how do you solve for that? And then we were talking earlier, like what happens if you want that at like a production grade, like that instance to scale really, really big? Like that is the future that's waiting.
Well, yeah, so think about the law of large numbers. So today, the point that I made previously, that the agentic use case is a lot of small things. But because of the law of large numbers, one of those small things will become big. And so I think the challenge of today, and we're working on that kind of relentlessly at Neon, is to anticipate that some of those small things will become very big. So not only you need to optimize for like this new scale dimension of just a lot of instances of whatever you're making, you need to make sure that each one of those instances, and you don't know which one, can grow based on the load you put on this system. Another point that you just made is we want to take that human environment and be able to replicate this human environment and give it to an agent. And so this is actually super useful as well because not only you want to give those environments to agents so they, I don't know, build software or something, or they do code gen and run code gen in the moment. I think we're going to have ephemeral software that is created and then destroyed as part of the chat interaction with AI. But I also think that's like those need to become RL environments, and eventually, maybe larger companies will start doing custom RL, and for that, you need those technologies as well.
So before I get into the RL one, which is interesting, and I'd like to touch back on that, there's one thing that we have found, especially with agentic use cases, is that when humans use things, when you as an infra provider, when you scale, it's usually like a linear sort of scaling for that day. Like you can anticipate how much compute you need, kind of today, plus minus a percentage. Now it's like flat, like it's slightly growing, then it's 10x needed. That exact moment. It's super bursty. And so how do you guys sort of solve for that?
We're not that bursty. We're not that bursty. We're bursty, we're like almost, I think like a step function, like this.
Yeah.
And the reason it's a step function is either something changes in the world, and now that step is kind of curves like an exponent. We're looking like at the number of active computes per day, and then at the number of instances we launch per day. And then for us, it's relatively smooth. But then we onboard a partner, you know,
and then
it creates a step function. The biggest change that we've had is when we onboarded Replit, and we onboarded Replit before Replit Agent showed up. And you know, it was human-driven consumption. We were also paid only, so it was like, you know, growing slowly, but not that many instances per day. And then on the day of the launch, I think it was 13,000 instances, you know, coming from like, I don't know, 100. And so that was shocking. The second thing happened when we started to support those dev environments. So now whatever we were doing, we multiplied by the number of dev environments per instance. And think about like just Postgres instances we need to put out to the world. In May last year, we got a black eye. We ran out of IP addresses, just spinning up those instances. And we solved it by, you know, like the specific detail, all compute instances per region were in one Kubernetes cluster. And that didn't scale. So the specific thing, we route out of IP addresses. Since that, we introduced the notion of a cell. We started putting, you know, only this many instances up into a cell. We were able to move compute between the cells. So I don't know, like that's what the new architecture does to you when you follow the learning curve of a new use case and keep improving those things.
But the funny thing is, and we've seen this as well, like every one of ours, originally it was to your point, it was like this and then 10x and then like this and then 10x. Now we do a lot of RL, which I'll touch on, and then RL are quite spiky. So we had Alex Shaw for Terminal Bench, and they're like, oh, I need 100,000 now, I need 1 million now. And that's like, but I need it spun up in a minute or 2 minutes, not over the next like 48 hours.
So I have an idea there, and maybe you can learn, it may or may not work for you, but the architectural decision that we had for Nian is we don't go to Amazon and say, hey, we don't let our users to choose what kind of a EC2 instance they want to launch. We actually procure very large bare metal instances from Amazon.
Go ahead.
And then we pack micro VMs inside those instances. So now, as long as they have bare metal capacity, we're good. So in everything, I think either production use cases or kind of back office analytical use cases. RL, I think, is a back office analytical use case. It's not a real time with user waiting, clicking, and waiting in response to an app. Analytical use cases have always been bursty. Right? Like if you look at, you know, I work at Databricks, right? So Databricks runs Spark. Spark is incredibly bursty, right? Yep. So when you run these big data transformations, you need a lot of compute for a small period of time, and then you don't want to pay for it. So I think that puts pressure on your architecture more than on our architecture. Our thing is more of just sustaining that kind of like traffic that keeps increasing and coming to the platform.
Yeah, but to your note, like we also run on bare metal, because the only way to do that very fast is if you already own the metal, and then when the burst comes, you just fill up the metal with sand.
Correct.
Because if you do it like, and there's other people that do it, where you offload it to EC2 or something like that, and that's fine for these predictable workloads because you can spin up the VMs as you need them.
On demand.
But on demand, you can't do that, right?
So I think, again, it's a little easier for us because we actually have a predictive model.
Yeah.
And the predictive model tells us how much compute we need every next, I don't know, minute or so.
Yeah.
And we run it continuously. And we have a warm pool.
Yeah.
I believe, I might be wrong, I believe that the amount of work that we do when we spin up a new instance is more than you, because we need to have Postgres running in this thing, and then Postgres needs to attach to our storage, remote storage. So that's all work, and therefore, and we want to do it in, I think, 300 milliseconds. So that requires us to keep a warm pool.
And how big is your warm pool? Like, how many instances do you have running at any given time?
I think I think it's less than like 3 to 5% of the overall fleet. So it's not terrible.
That's okay,
I think in smaller regions it's bigger, naturally. Basically, the more compute you run in a region, the less the warm pool is. And that's why we have a predictive model that tells us how much you need.
Because you guys use this bare metal as well, do you have like an idea of utilization across regions right now?
We do. I don't have a number in my head right now. Basically, there's a number of ways that you want to look at the problem. For compute, you want the utilization of compute. For storage, you want to look at write amplification. Write amplification, like every time you have any storage products, write amplification is the bane of your existence. In the early Neon, I think it was 10. In the later Neon, I think it's 1.1 to 1.2.
Yeah, we were talking about this earlier as well on the different workloads. So when we create sandboxes, we decided that they should not be just ephemeral workloads because we think sandbox, like agents can run for a long time. They want also the state and whatnot. And to be able to provide that, you also have to make sure that we have sort of like checkpoints, snapshots, history, backups that people do not see, right? And so there's a bunch of like networking IOPS there, storage, whatever. And then we found these use cases like RL, which is like, we don't need that at all. And they spin up 100,000 or 50,000 in 2 minutes and then run 1 million of them. And then that just like congests everything because we're doing the backups. And they don't really care. And so we then introduced like an ephemeral one where we don't do that at all and they're happy. So have you had any of these different?
Well, first of all, storage is a trip. Once you build storage and you make it multi-tenant and you need to large it at very, very large scale, and each tenant can be either small or incredibly large, it becomes a trip. And you're experiencing this with backups. We can geek out on this thing for a long time. However, if you actually invest into this and build it from first principles for your use case, then you will have this tremendous advantage because you have that storage and nobody else does. One of the things that's coming, like we talked earlier, is that some of those really small use cases will become large inevitably as people put production applications there and they're putting them out in the world. And maybe they're vibe coded, maybe not, who knows? But some of them will become popular and the demands for the infrastructure will become very large. So you will need to scale this. And so when people think about agentic architectures and they say, oh, of course you solve this like tiny use case at volume, but for a real system, you will need to go and migrate to something else, to something proven, EC2, or ES, whatever. Well, they underestimate the fact that we certainly see all of those use cases. We see how they grow. And one of our goals is to actually not match a single instance of Postgres, but I think with our architecture, we can improve it by at least a factor of 3 to 5 from this, surely by the fact that we separate storage.
Are you unique on that you separate the storage from the compute?
We're not unique. We're unique that we separate the storage and compute and support an agentic use case. So we can go from very, very small to very, very large. Supabase does not separate storage and compute, but they certainly support the very small use case at volume very well. Aurora separated storage and compute, but they don't have that agentic capability going from very, very small to very, very large. Now, I'm sure that nobody's asleep, so we always respect our competition. So I'm sure they're working on this. Certainly, I know that Aurora does because we hire a lot of people from Aurora, so we kind of get a little bit of a grapevine, not maybe high fidelity, but some. But I also think that some of the things that we'll do, I don't know, it's kind of super technical. Like I don't know if we want to talk about this or not. But some of the things we can do when you separate storage, it doesn't apply just to databases. It may apply to sandboxes as well. That you really unlock you actually free up CPU and make your computes be more performant than otherwise.
And how do you do that? Like, what do you use for the storage? What do you like? How do you attach that to the compute?
So storage, okay, so let's geek out a little bit. So storage is built from scratch. It's custom, and Postgres has this thing called write-ahead log. How many people know what write-ahead log is? Oh, we have like half. Okay, so the idea is that when you go and write something into Postgres, you type insert into T values 1, 2, 3. It creates what is called a log record that indicates what needs to be updated in storage. And storage is super dumb. It has 8 kilobyte pages. Those storage does not know about rows, columns, any of that. It has 8 kilobyte pages. And so what Postgres writes into the wall, write-ahead log, is which page and what's the difference in bytes that you need to apply to the page. Basically, how do you want to change that page? And then wall becomes a stream. Now, transactions go in parallel. Postgres serializes them, create the sequential stream of modifications to pages in storage. And so what Neon did is like, it just separated that storage and told Postgres, hey, send wall here to us. We'll figure it out, and we'll update pages in the remote storage. So it turns out, once you like really start digging deep into the Postgres internals, that every few minutes, Postgres wants to truncate the log, right? Because otherwise, this write-ahead log will grow indefinitely large. And that operation is called a checkpoint. Right after a checkpoint, there's a number of pages in Postgres that are called dirty pages. It will go, and each of those pages, it will write fully into the transaction log. That's called full page image. And so now, how do you measure how expensive is this operation? Well, the way to measure this operation is, again, to look at write amplification, right? How much more write-ahead log are you producing that you wouldn't otherwise if you just like turned it off. But you can't turn it off because otherwise you wouldn't be truncating the log. Turns out write amplification is roughly 3 to 8x when you do those full page images, and that also burns a whole bunch of CPU. So now that you're actually sending this data to remote storage, to us, to Neon storage, you don't need to do that at all. So that stuff we actually turn off. We haven't shipped it yet, but we will. And I think, I don't know yet, but we'll publish a bunch of blog posts and benchmarks. I think we'll increase Postgres throughput, just kind of apples to apples. You know, somebody running Postgres on NVMe versus this is like Postgres with separation, storage, and compute in Postgres. I think we'll improve it by a factor of 3 to 5x. But you know, fingers crossed.
Fingers crossed on that, yeah. And so that's definitely what's needed with agents. Just on that, like the number of users that are agents versus humans is 50-50 now. What's the
No. I think it's 90-10.
90-10.
Yeah, I think it's 90-10. I think 90% of instances spun up on a daily basis on Neon is 90% agents and 10% humans, and maybe more than 90%. I haven't checked recently. And the reason is like, you know, like, you probably look at your team. How many people on your team are actually writing code, right?
More agents than humans, for sure.
Right, more agents than humans, especially if you count agents as like Cloud Code recommends it and says, hey, would you like to spin up an instance of Neon? Yes.
Yeah.
We count this as an agentic use case. And of course, we count all our partners, such as Replit, and we have many, many more, I think like 30 or something, vibe coding platforms on Neon. That is definitely agents.
One question on this, and so just slightly less technical, but on the go-to-market, which I'm quite interested in as well. Whereas it was interesting, historically as a startup, you would either go PLG or enterprise first, like that's directionally what your company would be. But the interesting thing, especially for the agent use case, is that both the enterprise and the PLG, the developer, the people here, none of them have a history of workflows. And so you can essentially, and that is the market is demanding it, you can sell both the enterprise and the individual the exact same product. Now there's obviously like different ways of like selling and going through procurement and whatnot, but that has not been historically that, and you guys seem to also be selling to both of those. And so how was your experience? As you're a bit ahead of us.
I think it's product dependent, to be honest. I'm gonna say a few things. The first one, in every early market, And ours market is not an early market. Our market is a database market.
Yeah.
It's an old market. Your market is potentially a new market. Sandboxes, I mean, maybe we had it in the past, but like we didn't care as much. But now, because of the agentic use cases, we do. So in the early market, what happens is when you go to, small companies consume it because like they want to innovate.
Yep.
Large companies, they also want to innovate, and they can go to like Amazon and Google, to their existing vendors, and say, hey, can you give me sandboxes? And they're like, yeah, sure. Like here's sandboxes. Here's a Kubernetes or something like
Kubernetes,
this.
yeah.
And so the reality is that when the innovation pressure is high, they're forced to, like, they don't have time. So they will go and evaluate every single solution in this category when they need it. And then there's pressure to do something. So they will choose the best one. In an older market, they can afford to wait because the existing solutions work and new solutions, well, maybe they are incrementally better, but you probably can get by on the old solution as well. So those things roll much slower. And therefore, Neon's strategy for the enterprise for a long time was to ignore it.
Yep.
And go PLG only. When the agentic use case showed up, then enterprises showed up as well. The second thing I want to say is, when I say it's market dependent, when your market is developer driven, you can build a platform. I mean, good example in my space, in database space, is MongoDB. It started with developers, open source adoption, but it's squarely an enterprise company. Or another example is Stripe. It started with startups, but it's squarely an enterprise company that covers the whole space.
Yeah,
the space. So basically, if you go through developers, you probably, and what I mean by that is like probably like 90+% companies that build for developers should have a PLG offering. Because if you don't, you're so exposed to somebody who will, and developers would like it, and then developers is like, it's an enormous force. And it's been an enormous force since like, the Ballmer was jumping on stage and yelling, developers, developers, developers. So now, analytics, for example, Databricks is an like incredible company. Snowflake is an incredible company. It's our competition. And they went straight to enterprise. And they are incredibly successful at it. So, and MongoDB is also very, very successful, right? Like $1 billion in revenue. But they went developers first and then conquered enterprise.
So, I mean, Databricks and Snowflake seem to be sort of the counterexample to my examples, where when we were thinking about our company as well, like I've seen most companies that go bottom up first and then eventually up market are the ones that are more successful. So like GitHub is essentially, in my least perception, it's part of Microsoft's hard to see, more valuable than GitLab. Or like BlackBerry no longer exists, but iPhone was like a bottom up and whatnot. Twilio, compared to where I used to work at Infobip, which was tops down, Twilio is still more successful, and so that's always how I thought about that.
If you're successful in bottoms up, you have an opportunity to cover the whole space. The company which I admire and watching their enterprise adoption is Vercel, right? Yep. It's very complementary to Neon because they don't have their homegrown database offerings, and so Vercel plus Neon is like awesome. And then we try very, very hard so that this integration works super well. However, obviously, what's an enterprise version of Vercel?
That's my next question. What's it of that and of you? Yeah.
Well, I think it's just like AWS, basically, like clouds, right? Because I don't think like there's an enterprise only Vercel. But clouds make gigantically more money than Vercel right now, because they run arbitrary compute, not just JavaScript compute, and they have like Kubernetes. Of course, like it's off strategy for Vercel to expose Kubernetes. I think so. I don't know. Like that's the one that's like an interesting use case.
But what do you, when you guys saw the enterprise, is there like a BYOC variation of it, or is it all your cloud, or how do you guys think about that?
I hate BYOC with a passion. I think you need to have one product. You need to relentlessly improve this product. The lesson I learned is from Snowflake, to be honest. So Snowflake does not have BYOC. Famously, Snowflake back in 2013 or 14 said, we host your data.
Yeah.
And then there's a lot of WTFs from the market saying, never, over my dead body, I will give you my data and then rent it back from you.
Yeah.
Like this feels ridiculous. And then here we are, right? People are comfortable with this. So I think in this one, you need to hold the line. And the reason to that is, if you don't, you will fracture your product too early. If your product caters a very large market, like your product is useful for everyone, databases are useful for everyone. So at Neon, there was pressure to build BYOC Neon or in customer's account Neon or whatever, and we said no to all of them, and like with our head high. And we go look in the mirror saying, like, did we do...
Are we crazy? Yeah.
Are we crazy, right? People are offering us millions of dollars, but then you look at the growth dashboards, and you're like, well, what's $1 million? Like, it's a few days.
Yeah.
So, like, whatever.
So with that, we're out of time. Nikita, thank you so much. Neon also has a booth outside, so during the break, please do stop by. Thank you so much. Thank you, sir.